Algebra 2 skills number 41, exponential equations. Okay, next, solving an exponential equation. When you have one exponent, isolate the term with the exponent. Take the log or natural log of both sides. This slideshow will only have log. We'll talk about natural log in a different slideshow. Change the exponent to a coefficient and solve. So let's look at an example. By the way, an exponential equation, I didn't make a slide for that, but that's an equation that has a variable in the exponent. So you can see the variable in the exponent here. So first you're to isolate this term right here. So we subtract 9 from both sides. And at this point it may be tempting to divide by 2. That's not what you do. It's not going to help. What you want to do instead is take the log of both sides, which is perfectly fine as long as you do it to both sides. You keep it in balance. Log properties, which is another slideshow, state that this exponent can be written in the front. So it's fairly easy to show why that is. But if you take the log and what you're taking the log of has an exponent, that exponent may be written up front. That allows you to separate that log and essentially get the exponent down so you can work with it. So now I can divide both sides by the log of 2. On the left hand side that would cancel, leaving x minus 2. And then we have this to calculate. You'll need a calculator here. So same thing on the next slide. Log 3 divided by log 2 is rounded to the nearest thousandth is 1.585. Then you add 2 to both sides. Okay, so 3.585. Second example, again exponential because you have a variable in the exponent. Here we're going to divide by 4 so that that term, the exponent, is by itself. Again, you can't divide by 3 here. You're going to take the log of both sides, move the x plus 5 up front. That allows you to divide by log of 3. Okay, on a calculator, log of 6 divided by log of 3 is 1.631. Subtract 5 from both sides. Okay, so exponential equation with one exponent. Now, there's also a 2 exponent case, in which case you're going to get one exponent per side. We'll show you this. If necessary, get the same base, set the exponents equal to each other, and solve. Here's an example. Here we already have the same base, and the first rule was to get everything to one side, or actually get an exponent per side, and here we do have an exponent per side, so that's not an issue. So we can just drop the 7s. So the concept is this. If you've established equality here and the bases are the same, then the exponents have to be the same. Okay, so you're not actually taking a log here, you're just observing that fact. So 2x plus 5 equals 3x minus 1. From here it's basic algebra, subtract 2x from both sides. X minus 2x, 3x minus 2x, is x, and add 1. So x is 6. Second example of that, fourth example overall. Notice here we still have an exponential equation. We have one exponent per side. I colored this 4 in red here because we can't just drop the bases here because bases aren't equal. But I can make this 4 be 2 raised to the power. 4 is 2 squared. So notice the red there, what you see. And when you raise an exponent to an exponent, you multiply. So 2 distributed to x plus 5 is 2x plus 10. Now essentially we have example 3 all over again. Drop the 2's. Now basic algebra. Subtract x from both sides, and x equals -19. Exponential equation.